February 20th, 1943, Tunisia, North Africa. The captured American tank sat motionless on the hard-packed desert sand, abandoned after a hasty American retreat near Spatler. Standard Wehrmacht procedure dictated destroying enemy equipment or leaving it behind as worthless. But Oberleutnant Werner Rademacher of Panzerabteilung 501 had other plans. Get our best mechanics. I want this machine evaluated immediately. What the Afrika Korps tank specialists discovered over the next 4 days would fundamentally challenge everything German doctrine had taught them about armoured warfare. The vehicle bore the stenciled name War Daddy 2 on its bow. The small identification plate inside read Medium Tank M4A1. The Americans called it the Sherman. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The first shock came when they started the engine. The right cyclone radial roared to life on the first attempt, settling into a steady idle without hesitation. In 3 years of maintaining German tanks in the unforgiving African climate, none of the mechanics had witnessed such immediate mechanical obedience. Panzer IIIs required careful starting procedures. Panzer IVs demanded methodical warm-up sequences. The Maybach engines powering German armour were temperamental machines that punished careless operators. This American tank simply started and ran, as if mechanical reliability were something to be expected rather than hoped for. The senior mechanic, Feldwebel Klaus Hartmann, had maintained vehicles since the Polish campaign of 1939. He opened the engine compartment with professional skepticism, expecting typical American crude simplicity. What he found instead was revolutionary sophistication, disguised as straightforward engineering. Every component was accessible. Every bolt followed standard sizing. Color-coded wiring eliminated guesswork during field repairs. The air filtration system was designed for sandy conditions with serviceability clearly considered during the design phase. Most remarkably, the entire power plant could be removed as a single unit in under 12 hours, by a crew with basic mechanical training. Removing a Maybach engine from a Panzer IV required specialized equipment, factory-trained technicians, and 2 full days of careful work. The Americans had apparently designed this vehicle, expecting that farmhands and factory workers would need to maintain it under combat conditions, far from proper workshops, using whatever tools they could scrounge. Hartmann called his commanding officer over. "Herr Oberleutnant, this is extraordinary. The engineering philosophy is completely different from ours." Rademacher frowned. "German engineering remains the finest in the world, Feldwebel." The mechanic chose his words carefully. "Of course, Herr Oberleutnant, but this tank is designed by someone who understands what happens when things break in combat. Observe the transmission access. A single crewman can reach every major component without removing half the vehicle." The contrast between American and German tank design philosophy had been growing starker throughout 1942 and into 1943. Germany built tanks as precision instruments, emphasizing engineering excellence and sophisticated performance. Each component was crafted to exacting tolerances. Each system was optimized for theoretical maximum effectiveness. The Panzer program represented the apex of German mechanical engineering, incorporating the finest materials and most advanced manufacturing techniques available to the Reich. But precision came with profound costs that were becoming increasingly apparent in sustained combat operations. German tanks required constant maintenance by skilled technicians. Complex systems failed under field conditions. Specialized parts were difficult to replace in forward areas. The supply chain struggled to provide the specific components needed to keep sophisticated machines operational. Most critically, production remained limited by the very precision that made each tank individually excellent. The Sherman embodied a radically different approach. American designers had prioritized mass production, field maintainability, and operational reliability over engineering sophistication. The design accepted adequate performance if it meant the tank would work consistently under the worst possible conditions. Every component was standardized for interchangeability. Every system was simplified for ease of service. The entire philosophy assumed that large numbers of adequately performing tanks would prove more effective than small numbers of theoretically superior machines. Over the next 3 days, Rademacher's unit conducted exhaustive tests of the captured Sherman. They drove it across soft sand, where Panzer IIIs routinely became stuck. They loaded it beyond its rated capacity. They subjected it to the kind of sustained operation that revealed mechanical weaknesses in every German tank design. The Sherman absorbed everything without complaint. The suspension, using simple leaf springs rather than the sophisticated torsion bars favored by German engineers, proved remarkably durable. The tracks, wider than those fitted to comparable Panzer models, distributed weight more effectively across soft terrain. The transmission shifted smoothly through its gears, without the grinding hesitation that plagued German gearboxes in sandy conditions. Most impressively, the engine maintained consistent power output, hour after hour, without overheating or requiring constant adjustment. Word spread through the Afrika Korps with remarkable speed. The Americans possessed a tank that outperformed German equipment in almost every measure of actual combat utility. Officers from neighboring units arrived to examine the captured machine. The pattern of reactions followed a predictable progression. Initial dismissive skepticism gave way to grudging technical respect, which transformed into genuine dismay as the implications became unavoidable. Hauptmann Friedrich Weber, a supply officer who had worked in German automotive plants before the war, spent an afternoon methodically studying the Sherman. His assessment was delivered with uncomfortable directness to the assembled officers and senior NCOs. This represents a fundamental difference in manufacturing philosophy. We design vehicles to achieve engineering perfection. The Americans design them to be produced by the millions. In total war, that distinction matters decisively. He gestured toward the engine compartment, inviting the officers to examine what he was describing. Consider this power plant. The engine block is cast rather than machined to fine tolerances. The Americans deliberately sacrifice a small amount of maximum performance in exchange for massive gains in production speed and simplicity. They can train a semi-skilled worker to assemble one of these engines in a fraction of the time it takes our skilled craftsmen to build a comparable Maybach unit. Now multiply that advantage across every single component in the vehicle. Weber pointed to the stamped metal body panels and hull sections. These panels appear crude compared to our precision-welded armor, but they can be produced by the thousands per day in factories that previously manufactured household appliances and agricultural equipment. The Americans have mobilized their entire industrial economy for war production. Every refrigerator factory, every washing machine plant, every commercial vehicle manufacturer has converted to military output. We cannot match this production capacity. We lack both the industrial base and the philosophical approach. The officers maintained uncomfortable silence. Weber had articulated what many had begun to suspect through months of combat against seemingly endless American material superiority. Germany's peacetime philosophy of emphasizing quality and precision engineering made perfect sense when producing limited quantities of civilian goods for discriminating customers. But in total war, the American approach of adequate products delivered quickly in overwhelming quantities was proving devastatingly effective. That evening, Feldwebel Hartmann compiled a detailed technical report documenting every aspect of the Sherman's design. He noted both strengths and weaknesses with professional thoroughness. The gun was adequate but unimpressive. The armor protection was sufficient against most anti-tank weapons but vulnerable to German 88mm guns. The crew comfort was surprisingly good, with more internal space than comparable German designs. The vision devices for the crew were effective and well positioned, but the report's most significant sections focused on reliability and maintainability. The Sherman could operate continuously for days with minimal servicing. Components that did fail could be replaced quickly using standard tools. The entire supply chain was designed around interchangeable parts that could be cannibalized from other vehicles if necessary. Most importantly, the tank worked consistently under conditions that would have crippled more sophisticated German designs. The report made its way up the chain of command. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. joining thousands of similar documents flooding into Wehrmacht headquarters from every combat theatre. German mechanics and engineers were encountering American equipment with increasing frequency throughout 1942 and early 1943. The assessments were uniformly troubling for German strategic planners. American factories were outproducing German industry at ratios that seemed physically impossible. In late 1942, Wehrmacht intelligence commissioned a comprehensive study of Allied vehicle production capacity. The results confirmed German commanders' worst strategic fears. American factories were completing military vehicles at rates exceeding thousands per day across all categories. Ford's Willow Run plant alone was finishing a B-24 Liberator bomber every 63 minutes at peak production. American shipyards were launching Liberty cargo ships faster than German U-boats could sink them despite the Reich's substantial submarine fleet. The statistics revealed a sobering truth about industrial warfare. American production capacity exceeded German output by factors of 5 to 1 in some categories, approaching 10 to 1 in others. The Soviet Union, despite having lost substantial industrial regions to German occupation, was outproducing Germany in tanks by significant margins. Britain, though smaller in population and resources, maintained higher production rates than Germany in several critical categories. The Axis powers were being buried under an avalanche of Allied material production that no amount of tactical skill or operational brilliance could overcome. Rademacher's unit kept the captured Sherman operational for 3 months, using it alongside their German tanks. The contrast in daily operations was instructive and increasingly frustrating. The Sherman started reliably every morning regardless of conditions. German tanks often required extensive preparation before operations could commence. The Sherman required approximately 1 hour of maintenance per 10 hours of operation. Comparable German tanks demanded 3 to 5 hours of maintenance for the same operational period. Most significantly, the Sherman remained operational. German tanks in the Afrika Korps spent nearly 40% of their time undergoing repairs or awaiting parts. The Sherman required repairs twice during its 3 months of Wehrmacht service, both times for relatively minor issues that mechanics resolved in under 6 hours using improvised methods. The reliability differential was not merely statistically significant, it was tactically decisive. But in February 1943, the Wehrmacht in North Africa had no concept of what American industry would deliver to European battlefields in the coming years. They had examined an M4A3 Sherman powered by a right radial engine producing 350 horsepower. They had no knowledge of the M4A3 variant then entering mass production in American factories. They could not imagine what Ford Motor Company had engineered specifically for armored warfare. The M4A3 represented the culmination of American tank engine development. Ford engineers had designed a purpose-built tank power plant designated the GAA, an all-aluminum V8 producing 500 horsepower at 2,600 revolutions per minute. The engine displaced 1,100 cubic inches, making it the largest gasoline-powered aluminum V8 ever manufactured. The design incorporated sophisticated features that German engineers would have considered appropriate only for aircraft applications. The GAA featured dual overhead camshafts, operating 4 valves per cylinder. The entire system used no belts or chains, with all accessories driven by gears and shafts for maximum reliability. Twin carburetors and dual magnetos provided complete redundancy in the fuel and ignition systems. The crankshaft was a flat-plane design that balanced power delivery across all cylinders. Most impressively, the entire engine weighed 709 kilograms while producing 100 horsepower more than the right radial that had powered earlier Sherman variants. Ford began installing the GAA in Sherman tanks in June 1942, with production ramping up steadily through 1943. The M4A3 became the United States Army's preferred Sherman variant, reserved almost exclusively for American forces rather than being distributed through Lend-Lease programs. The diesel-powered M4A2 went to the Soviet Union and U.S. Marine Corps. The Chrysler Multibank A57 engine-powered M4A4s supplied to British and other Allied forces. But the GAA-equipped M4A3 remained American armor. The performance difference was substantial and immediately apparent. The M4A3 weighed 69,637 pounds, fully loaded, slightly less than the standard M4, despite the heavier engine. The increased power provided significantly better performance across all measures. Maximum road speed reached 47 km per hour, faster than any mass-produced German tank except the governed Panther. More importantly, the M4A3 maintained higher sustained speeds during extended operations. Average operational speed during extended trials reached 14.89 km per hour, faster than any other Sherman variant and comparable to the best German designs. But the critical advantage lay in reliability. During comprehensive trials at Aberdeen Proving Grounds in winter 1943–44, the Ford GAA demonstrated unprecedented endurance. 4 examples of each major Sherman variant underwent testing to 4,000 miles or 400 engine hours. The GAA engines averaged 255 hours before requiring major service, exceeding every other power plant tested. The competing right radial averaged only 218 hours. The German Maybach engines powering captured Panzer IVs typically required major service after approximately 200 hours of operation. More significantly, the GAA required only 110 man-hours of service during the testing period. The right radial demanded 132 man-hours. The diesel GM engines in the M4A2 required 143 man-hours. The Chrysler multibank needed just 45 man-hours, but produced insufficient power for combat requirements. The GAA provided the optimal combination of power output, fuel efficiency, and maintainability that American doctrine demanded. Ford manufactured 1,690 M4A3 tanks between May 1942 and December 1943 when they ceased tank production to focus on other war materials. Fisher Tank Arsenal at Grand Blanc, Michigan, and Chrysler's Detroit Tank Arsenal continued production, ultimately building 12,596 M4A3 tanks in various configurations. The variant became the foundation for American armor development, with the GAA engine powering the M4A3E2 jumbo assault tank, the M4A3R3 Zippo flamethrower tank, and ultimately the M26 Pershing heavy tank that would succeed the Sherman. But in early 1943, Wehrmacht commanders in Tunisia had no knowledge of American production plans or the superior variants entering service. They understood only that the Americans possessed significant industrial capacity and were deploying increasingly capable equipment. The captured Sherman demonstrated that American engineering, while philosophically different from German approaches, produced effective combat vehicles suitable for mass production and sustained operations. The lessons learned from examining captured American equipment would influence German thinking throughout the remainder of the war, though understanding the problem and solving it proved entirely different challenges. Germany lacked the industrial base to match American production. The Nazi leadership hesitated to fully mobilize the civilian economy for war production until far too late. Strategic bombing disrupted German manufacturing, just as production was finally expanding. Most fundamentally, German engineering culture remained committed to sophisticated designs that were difficult to mass produce and maintain. The story of how Wehrmacht crews came to truly understand American tank superiority begins not with the captured Sherman in Tunisia, but 18 months later on a very different battlefield, September 8, 1944, near Aachen, Germany. The western frontier of the Reich itself, Oberfeldwebel Ernst Bäumer commanded a Panther OSV-A in the 5th Panzer Army's desperate defense against the American First Army's advance toward German soil. His tank represented the cutting edge of German armor development. The Panther mounted a 75mm KOK-42 L-70 gun with devastating armor penetration capability. Sloped frontal armor up to 120mm thick made it nearly impervious to most Allied anti-tank weapons at combat ranges. The Maybach HL-230P30 engine produced 700 horsepower, theoretically giving the 45-ton vehicle excellent mobility. German propaganda proclaimed the Panther the finest tank in the world, superior to anything the Allies fielded. But Bäumer had learned harsh truths about the Panther during months of combat on the Eastern Front. The sophisticated interleaved road wheel suspension, designed to distribute weight and reduce ground pressure, packed solid with mud in wet conditions, freezing overnight and immobilizing the tank. The complex transmission failed regularly, requiring specialized replacement that could take days when parts were available. The final drive, inadequately designed for the vehicle's weight, broke frequently under operational stress. Most critically, the engine overheated constantly, despite the sophisticated cooling system, requiring nearly constant monitoring and adjustment. The Panther was governed to 2,500 revolutions per minute, after early production models demonstrated catastrophic engine failures at higher speeds. This limitation reduced power output to 600 horsepower and dropped maximum road speed from 55 km per hour to 46. Even with this governing, the engine required major overhaul every 1,000 kilometers under ideal conditions. Combat operations cut that interval dramatically. Bäumer's unit considered it a minor miracle when a Panther completed a week of operations without mechanical failure. On that September morning, Bäumer's Panther sat disabled beside a muddy farm track 3 kilometers behind the front lines. The final drive had failed during the previous day's fighting. The company's single recovery vehicle, a converted Panther itself, had broken down while attempting the recovery. A replacement final drive had been promised by division headquarters, but would take at least 3 days to arrive from depot stocks in the rear. In the meantime, Bäumer's crew waited beside their immobilized tank while American forces pressed steadily eastward. The sound of tank engines approaching from the west brought the crew to full alert. Bäumer raised his binoculars, expecting to see German reinforcements. Instead, a column of American armor emerged from the morning fog, moving rapidly along the farm track directly toward their position. The crew scrambled for their personal weapons, preparing to destroy their disabled tank and escape. But something about the approaching vehicles made Bäumer pause. The lead tank was definitely American, probably a Sherman based on the distinctive profile. But something was different about its performance. The tank was moving faster than Bäumer had seen Shermans travel in combat conditions. The engine note was different, smoother, and more powerful than the typical Sherman sound. Most remarkably, the entire column of 5 tanks was maintaining formation and speed across muddy terrain that would have slowed German armor considerably. The American column passed within 200 meters of Bäumer's position without detecting the disabled German tank in the tree line. Bäumer watched through his commander's optics as the Shermans disappeared eastward, moving at sustained speed that seemed impossible for vehicles of that weight. After confirming the Americans had passed, Bäumer consulted his crew. That was not normal Sherman performance. The loader, who had fought in North Africa before being transferred to the Western Front, agreed immediately. Those tanks were faster than anything we saw in Tunisia. Different engine sound too, more powerful. 2 days later, Bäumer's Panther finally received its replacement final drive and returned to operational status. The unit was ordered to establish defensive positions near a crossroads 3 kilometers east of their previous location. They arrived after dark to find an unexpected scene. An American M4A3 Sherman sat abandoned in perfect mechanical condition near the crossroads, apparently left behind when American forces had rapidly advanced past the position earlier that day. The battalion commander, Major Hans Kessler, immediately ordered the tank secured and evaluated. Bäumer's crew, having the most experience with captured American equipment from North Africa, was assigned to conduct the technical assessment. At first light on September 11, 1944, Bäumer and his crew began their examination of the captured M4A3 Sherman. What they discovered over the next 8 hours would fundamentally change their understanding of American armored capability. The first revelation came when the driver, Unteroffizier Peter Schmidt, started the engine. The Ford GAA V8 roared to life with immediate power that shocked everyone present. Schmidt had started hundreds of German tank engines during his 5 years of service. He had never experienced an engine that responded with such instantaneous, confident mechanical authority. The idle was smooth and steady without adjustment. The throttle response was immediate and progressive. Most remarkably, within 30 seconds the engine had reached full operating temperature and was ready for sustained operations. A Maybach HL-230 and a Panther required careful warming procedures taking 5 to 10 minutes before the vehicle could safely operate under load. Premature operation caused accelerated wear and increased failure rates. The American engine simply worked immediately, as if mechanical reliability were an engineering assumption rather than a hopeful aspiration. Schmidt called to Bäumer with barely contained excitement. "Herr Oberfeldwebel, you need to feel this. The power delivery is completely different from anything German." Bäumer climbed into the driver's position, while Schmidt moved to the assistant driver's seat to provide guidance on the controls. The control layout was intuitive, with clearly labeled instruments and straightforward operating procedures. Bäumer released the parking brake, engaged first gear, and applied throttle. The Sherman surged forward with smooth, progressive power that reminded him more of a powerful automobile than a military tank. The transmission shifted cleanly through the gears without grinding or hesitation. The steering required less effort than comparable German systems. Most impressively, the engine pulled strongly across the entire power band without the dead spots and hesitation that characterized German tank engines. Bäumer drove the Sherman along the farm tracks and across open fields for 45 minutes, gradually increasing speed and evaluating performance. Schmidt timed their runs with a stopwatch and plotted their route on a map. The results were extraordinary and deeply troubling. On level dirt roads, the Sherman reached 47 km per hour in top gear, maintaining that speed effortlessly. The Panther was theoretically capable of 46 km per hour, but rarely achieved that speed in actual operations due to transmission limitations and engine governing. More significantly, the Sherman maintained higher sustained speeds across rough terrain. Crossing a ploughed field at tactical speed, the Sherman averaged 32 km per hour. Bäumer's Panther typically managed 25 km per hour under similar conditions. The wider tracks and simpler suspension absorbed ground, irregularities without the constant speed variations that plagued German designs with their complex interleaved wheels. Schmidt completed his calculations and presented them to Bäumer with visible concern. "Herr Oberfeldwebel, based on our test runs, this Sherman would cover 100 kilometers of mixed terrain in approximately 3 hours and 15 minutes. Our Panther would require 4 hours and 30 minutes for the same distance, assuming no mechanical failures. The Sherman has a decisive operational mobility advantage." The implications were strategically profound. Tactical mobility meant everything in armored warfare: the ability to reach critical positions faster than the enemy, to exploit breakthroughs before defenses could solidify, to reinforce threatened sectors ahead of counterattacks. These capabilities often determined battle outcomes more decisively than firepower or armor protection. The Americans possessed tanks that could simply move faster over realistic terrain for sustained periods. This advantage, multiplied across hundreds or thousands of vehicles, became overwhelming. But the true shock came when the crew examined the engine compartment in detail. Bäumer had served as a tank mechanic before receiving his commission as an NCO. He understood German tank engines thoroughly, having performed countless repairs and overhauls. Opening the Sherman's engine deck revealed engineering philosophy that bordered on revolutionary compared to German approaches. The Ford GAA sat in its compartment with every major component readily accessible. Color-coded hoses and wiring eliminated guesswork during field repairs. The air filtration system could be serviced in minutes without tools. The oil filter, fuel pumps, and water pumps were positioned for easy access and replacement. Most remarkably, the entire engine was mounted on a subframe that could be unbolted and removed as a single unit using basic equipment. Bäumer called the rest of his crew over to observe what he was showing them. "Gentlemen, examine this carefully. This engine produces 500 horsepower, more than our Maybach generates even before governing. Yet it is designed for field maintenance by minimally trained personnel. Notice how every connection uses standard fittings. Observe how the accessory drive system is completely enclosed and gear-driven rather than using belts that fail. See how the entire assembly can be removed and replaced without specialized tools or factory training. The loader, Oberfeldwebel Hans Zimmermann, who had worked as an automotive mechanic in civilian life, was examining the engine with professional fascination. "This is extraordinary engineering, Herr Oberfeldwebel. The Germans would never build an engine this way. We would optimize every component for maximum performance, accepting maintenance complexity as necessary. The Americans have designed for reliability and serviceability, accepting slightly reduced theoretical performance. In sustained operations, their approach is clearly superior." The gunner, Unteroffizier Wolfgang Meyer, raised the obvious question that troubled everyone. If the Americans can build engines like this, producing 500 horsepower with superior reliability, why are we told that German engineering is the finest in the world? How many of these tanks do they have? The answer to Meyer's question would have horrified the crew had they known the full truth. By September 1944, American factories had produced more than 37,000 M4 Sherman tanks in all variants. The M4A3 with the Ford GAA engine accounted for more than 12,000 of that total, with production continuing at over 300 units per month. Compare those figures to German production. Total Panther production from 1943 through the end of 1944 reached approximately 5,000 units. Panzer IV production, Germany's most numerous tank, totaled roughly 8,000 units across the entire war. The Americans were outproducing Germany by factors of 4 to 1 in comparable medium tanks, and that ratio was actually improving in America's favor as German production facilities suffered from Allied bombing and resource shortages. But the production disparity told only part of the story. The critical difference lay in operational availability, the percentage of vehicles actually ready for combat at any given moment. Wehrmacht armored divisions rarely had more than 60% of their tanks operational. The complex maintenance requirements, unreliable components, and inadequate spare parts supply meant that substantial numbers of German tanks sat disabled, awaiting repairs or replacement parts at any given time. American armored divisions typically maintained 80 to 90% operational availability. The simpler designs, standardized components, and massive spare parts production meant that American tanks stayed in action. A Sherman that did require repair was often back in service within 24 hours. A Panther requiring similar repairs might wait days or weeks for parts that were produced in insufficient quantities by manufacturers struggling under Allied bombing. The mathematical reality was devastating for German prospects. If Germany fielded 100 Panthers against 200 Shermans, the actual combat would involve 60 operational Panthers against 170 operational Shermans. The numerical disadvantage was even worse than the production figures suggested. German crews were fighting outnumbered more than 2 to 1 before the first shot was fired, purely because American tanks worked more reliably. Major Kessler arrived that afternoon to review Bäumer's findings. The crew demonstrated the Sherman's performance and walked the Major through their technical assessment. Kessler listened with the expression of a man having his worst suspicions confirmed. "Gentlemen, what you have discovered here is not new to higher command. Intelligence reports from all fronts confirm that American equipment consistently demonstrates superior reliability and maintainability compared to our designs. The question is why, and what it means for our strategic position." He gestured for the crew to gather around the Sherman's engine compartment while he explained the larger context. German industry developed in a fundamentally different environment than American manufacturing. We emphasized craft production, where skilled workers built sophisticated products in relatively small quantities. This approach excels at producing high-quality luxury goods for discriminating customers who can afford premium prices. It performs adequately when producing military equipment in limited quantities for professional peacetime forces. But we are now fighting total war against enemies who possess vastly larger industrial capacity organized around mass production principles. The Americans learned to manufacture complex products in enormous quantities using semi-skilled workers and standardized components. They applied these methods to automotive production decades ago. Now they have simply transferred the same philosophy to military equipment. Kessler pointed to the Ford engine sitting in its mount. This power plant represents American manufacturing philosophy, perfected over 40 years of experience. Henry Ford pioneered moving assembly lines and interchangeable parts in the early 1900s. American automobile companies refined these methods across millions of vehicles. They understand how to design products that can be manufactured by the millions and maintained in the field with minimal training. We are fighting an industrial system specifically designed for exactly this type of challenge. The crew absorbed this explanation in uncomfortable silence. Schmidt finally asked the question they were all thinking. Herr Major, if we understand these principles, why do we not adopt them? Why do we continue building sophisticated tanks that break down constantly when simpler, more reliable designs would serve better? Kessler's answer was delivered with visible frustration. Industrial philosophy cannot be changed overnight, Unteroffizier. Our manufacturing infrastructure, our engineering culture, our training systems, our entire approach to production developed over generations. The Americans built their system over 40 years of peacetime automotive production. We recognized the advantages of their methods in 1942, far too late to restructure our entire industrial base. We make improvements where possible, but fundamental change requires time and resources we no longer possess. He paused, then added with bitter honesty. Furthermore, certain individuals in positions of authority remain convinced that German engineering excellence will overcome American numerical superiority. They believe that superior performance in individual vehicles will prove decisive, despite overwhelming evidence that reliability and numbers matter more than sophisticated specifications. This delusion persists at the highest levels despite mounting evidence to the contrary. Bäumer and his crew spent 3 additional days with the captured Sherman, conducting exhaustive testing under operational conditions. They drove it across every type of terrain in the area. They simulated combat maneuvers, rapid repositioning, and sustained operations. They subjected the engine to maximum stress, running at high speed for extended periods. They performed field maintenance using only the tools carried aboard the tank. Every test confirmed the same basic conclusions. The Sherman was faster in actual operations than comparable German tanks. It was dramatically more reliable, running for hours without requiring attention. It was designed for field maintenance by ordinary soldiers rather than specialized technicians. Most importantly, it worked consistently, under conditions that would have caused German tanks to fail. The engineering sophistication was hidden beneath straightforward design that prioritized function over theoretical performance. On September 15, 1944, Bäumer's unit received orders to abandon their positions and withdraw eastward ahead of the American advance. They destroyed the captured Sherman before withdrawing, following standard procedure for abandoned equipment. Bäumer watched the American tank burn with conflicting emotions. The Sherman had taught them truths about industrial warfare that contradicted everything German propaganda had proclaimed. German engineering was not inherently superior. Sophisticated design did not guarantee battlefield success. The side that fielded more tanks that actually worked would win regardless of theoretical performance advantages. That evening, as his Panther rumbled eastward in the growing darkness, Bäumer reflected on the implications of what they had learned. The Americans possessed not just numerical superiority, but fundamental advantages in reliability and operational mobility. Every German tank that broke down and awaited repairs represented a tactical disadvantage that American forces exploited ruthlessly. Every kilometer that American armor could travel faster than German tanks translated into strategic mobility that determined which force controlled critical terrain. The mathematics were inexorable. Germany was losing the war not primarily through inferior tactics or inadequate courage, but through industrial inadequacy masked by propaganda about engineering excellence. The Americans had built exactly the right tanks for industrial warfare, prioritizing reliability and production over sophisticated performance. That approach was proving decisively superior on every front. The final chapter of this story unfolds not on the battlefield, but in the quiet years after Germany's defeat, when former Wehrmacht tank crews could finally speak honestly about what they had experienced. The transformation of understanding, from wartime propaganda to post-war reality, reveals how thoroughly the Sherman had educated an entire generation of German armoured warfare specialists. In April 1945, as the Reich collapsed under the weight of Allied advances from east and west, Oberfeldwebel Bäumer surrendered to American forces near Cassel. His Panther had been abandoned 3 days earlier, after the transmission failed for the third time in 2 weeks. No replacement parts existed. No recovery vehicles remained operational. The crew simply removed the breech block from the main gun, destroyed the radios, and walked away from a tank that had cost the Reich 117,000 Reichsmarks and countless man-hours to produce. Bäumer spent 18 months in a prisoner of war camp in France, assigned to a motor pool maintaining American vehicles. The experience completed his education in American mechanical philosophy. He worked on Sherman tanks, GMC trucks, jeeps, and various other American military equipment. Every vehicle reinforced the same lessons he had learned from the captured M4A3 in September 1944. American equipment was designed to work reliably under abuse, to be maintained by minimally trained personnel, and to be produced in quantities that overwhelmed any qualitative advantages their opponents might possess. The motor pool sergeant, a career mechanic from Detroit named Bill Harrison, befriended Bäumer and explained American automotive philosophy during their long shifts together. "We don't build vehicles to be perfect, Ernst. We build them to work consistently and to be manufactured by the millions." Henry Ford figured out 40 years ago that making 1 million adequate products beats making 1,000 perfect ones. The war just proved he was right on a bigger scale. Harrison walked Bäumer through a Sherman engine overhaul, explaining design choices that prioritized reliability over performance. "See how everything's accessible? That's not accident. Engineers designed this, knowing some kid from Iowa who'd never seen a tank before would need to fix it in a muddy field with basic tools. They made it simple on purpose. Simple means it works when you need it, and that matters more than impressive specifications." Bäumer absorbed these lessons with the intensity of someone who had paid dearly for not understanding them earlier. He had watched friends die in disabled German tanks that broke down at critical moments. He had seen entire operations fail because sophisticated German equipment could not be maintained in field conditions. He had experienced firsthand the crushing weight of American material superiority enabled by reliability and mass production. The education was expensive, but thorough. When Bäumer returned to Germany in late 1946, he found a nation struggling to comprehend the magnitude of its defeat and the lessons that might be drawn from catastrophe. The cities lay in ruins. The economy had collapsed. The industrial infrastructure that had produced tigers and panthers now struggled to manufacture basic necessities. In this environment of survival and gradual recovery, former Wehrmacht personnel began sharing experiences and attempting to understand what had gone wrong. Bäumer found work at a small automotive repair shop in Stuttgart, where the owner, a former Luftwaffe mechanic, was attempting to restart civilian vehicle production. The conversations in that shop, repeated in thousands of similar workshops across Germany, began the process of cultural transformation. German mechanics who had maintained Wehrmacht equipment discussed what they had learned from American and British vehicles. They compared design philosophies. They analyzed what had worked and what had failed. The consensus emerged gradually but definitively. German engineering had emphasized sophistication and theoretical performance at the expense of reliability and manufacturability. This approach made sense for producing luxury automobiles in limited quantities for wealthy customers. It was catastrophically inadequate for producing military equipment in total war against opponents who understood mass production. The Americans had not won through superior engineering in the traditional German sense. They had won through superior manufacturing philosophy that recognized reliability mattered more than sophistication. In 1952, Bäumer attended a reunion of former 5th Panzer Army veterans at a Gasthaus near Munich. More than 200 men gathered, ranging in age from their late 20s to their 60s, united by shared experiences in German armor. The conversations ranged across familiar territory, battles fought, comrades lost, the strange mixture of pride in their service and relief that the war had ended. But one topic dominated discussions whenever technical matters arose: American tanks and what German crews had learned from encountering them. An elderly former Oberst who had commanded a Panzer regiment on the Eastern Front stood during the evening's formal gathering and offered reflections that captured the group's collective understanding. "Gentlemen, we fought with courage and skill, using equipment we were told was the finest in the world. We believed that German engineering excellence would prove decisive. We were wrong, and that error cost Germany the war and cost many of our comrades their lives. The Americans built tanks that were adequately armed, adequately armored, and above all, reliable. They built them by the tens of thousands, using manufacturing methods we did not understand and could not replicate. Their Sherman tank was not perfect, but it worked consistently, and that mattered infinitely more than our sophisticated designs that broke down constantly. We learned this lesson vehicle by vehicle, engagement by engagement, but we learned it too late, and to change the outcome." He paused, looking around the room at the assembled veterans before continuing. "The Americans taught us that in modern industrial warfare, the side that fields more equipment that actually works will defeat the side with smaller numbers of theoretically superior machines. This lesson applies far beyond military equipment. As we rebuild our nation and our industry, we must remember that reliability, manufacturability, and practical function matter more than impressive specifications or sophisticated complexity." The room remained silent for a long moment before someone began applauding. The applause spread until the entire gathering was acknowledging a truth most had recognized individually, but were now accepting collectively. German engineering had to evolve, incorporating American lessons about practical reliability while maintaining German attention to quality. The hybrid approach, combining the best of both philosophies, would become the foundation for West Germany's post-war industrial miracle. By 1960, this transformation was well underway in multiple industries. Volkswagen, resurrected from its wartime origins, applied mass production methods to affordable civilian vehicles while maintaining quality standards. Mercedes-Benz combined luxury with unprecedented reliability. Porsche developed sports cars that were both sophisticated and dependable. German machine tool manufacturers emphasized precision that could be replicated consistently across large production runs. The reputation of German engineering was being rebuilt on different foundations that acknowledged American lessons. Bäumer, by then managing a successful automotive service business, trained young mechanics in principles that reflected this evolved understanding. Build for reliability first, performance second. Design for maintenance from the beginning. Use standard components wherever possible. Test under realistic conditions, not just ideal circumstances. These principles, learned through defeat and refined through observation of American methods, became standard practice in West German industry. In 1973, Bäumer attended an international automotive engineering conference in Frankfurt, where American and German engineers presented papers on design philosophy. During a panel discussion, a young German engineer asked whether German approaches had become too heavily influenced by American methods, losing the sophisticated craftsmanship that had made German products legendary. An elderly American engineer who had worked on Sherman power plant development responded before Bäumer could. "Young man, the Sherman tank won World War II not because it was perfect, but because it worked consistently and we could build thousands of them." That philosophy came from 40 years of American automotive experience, but it wasn't invented here. We learned it by trial and error, making millions of vehicles and figuring out what mattered. Your country learned the same lessons the hard way during the war. Now, you've combined our emphasis on reliability with your traditional attention to quality, and you're building products that are genuinely world-class. That's not abandoning your heritage. That's learning from experience. Bäumer raised his hand and was recognized by the moderator. "I served in German armor during the war. I personally examined captured American tanks and learned to respect their engineering philosophy. Everything this gentleman says is correct. We learned through painful experience that reliability matters more than theoretical performance, that designing for manufacture matters as much as designing for function, and that equipment which works consistently will defeat sophisticated equipment that fails regularly. These lessons cost Germany the war. They also helped us rebuild successfully afterward. The conference continued with detailed technical discussions about specific design challenges and solutions, but the fundamental understanding was universal among the participants. Modern industrial production required combining sophisticated engineering with practical reliability. Mass production demanded designing for manufacture as carefully as designing for function. Equipment that worked consistently under real-world conditions would always outperform theoretically superior designs that failed in practice. In May 1985, the 40th anniversary of Germany's surrender brought renewed interest in World War II, history and veterans' experiences. A German documentary film crew interviewed Bäumer about his wartime service in armored forces. The interview, conducted in his office, surrounded by photographs and memorabilia from his post-war career in automotive engineering, focused on lessons learned from the war. The interviewer asked the obvious question: what was the most important thing you learned during your military service? Bäumer's response was immediate and definitive. I learned that propaganda lies, and reality teaches hard truths. We were told German engineering was superior, that our sophisticated tanks would defeat American numerical superiority. The reality was that American tanks worked more reliably, moved faster in actual operations, and were produced in quantities we could not match. They won not through superior individual performance, but through superior industrial philosophy. The documentary included Bäumer's response, along with similar reflections from other veterans. The program aired in autumn 1985 and generated substantial discussion in German media about lessons from the war and their application to contemporary challenges. The consensus among viewers and commentators was striking. Germany had learned necessary humility through defeat, studied successful approaches from former enemies, and built a more effective industrial culture by combining the best of German and American methods. Bäumer passed away in 1992 at age 73, having spent 46 years in automotive engineering after his wartime service. His obituary in the Stuttgart newspaper noted his wartime service but focused on his post-war contributions to German automotive industry and his role in training a generation of mechanics in modern maintenance and engineering principles. The notice included a quote from a speech he had given at a technical school graduation. Good engineering means building equipment that works reliably when needed, not equipment that impresses in specifications but fails in practice. The final irony of the Sherman story reveals itself in contemporary military vehicle development. Modern main battle tanks incorporate design principles that the M4A3 Sherman demonstrated 80 years ago. Powerful, reliable engines designed for field maintenance, standardized components for ease of replacement, emphasis on operational readiness over theoretical performance, recognition that tactical mobility depends on sustained speed rather than maximum specifications. The American tank that Wehrmacht crews admitted outran every Panzer they had was teaching lessons that still influence armored vehicle design worldwide. The Ford GAA engine, which so impressed German mechanics examining captured Shermans, represents a pinnacle of World War II power plant development that remains instructive. 500 horsepower from a naturally aspirated gasoline engine using 1940s technology, all aluminum construction decades before that became standard. Dual overhead camshafts and 4-valve cylinder heads in a military application. Complete accessory drive system using gears rather than belts for maximum reliability. The engineering was sophisticated by any standard, but the sophistication served practical reliability rather than theoretical performance. Modern engineers studying the GAA marvel at how Ford achieved such advanced design while maintaining manufacturability and field serviceability. The engine could be produced by semi-skilled workers using mass production techniques. It could be maintained in field conditions by soldiers with basic mechanical training. It ran reliably for hundreds of hours between major service intervals. It powered thousands of tanks that remained operational across years of sustained combat. This combination of advanced engineering and practical reliability represents exactly what German industry struggled to achieve during the war and spent decades learning afterward. The M4A3 Sherman itself, the complete vehicle that Bäumer's crew evaluated in September 1944, embodied lessons about industrial warfare that transcended its immediate tactical significance. The tank was not perfect by any measure. The armor was adequate but not outstanding. The gun was effective against most targets but inferior to German tank weapons. The crew comfort was reasonable but not exceptional. But the Sherman worked consistently under the worst possible conditions, and that reliability, multiplied across thousands of vehicles, proved strategically decisive. Wehrmacht crews who drove captured Shermans understood this truth through direct experience. The American tanks started reliably every morning. They ran all day without constant attention. They required less maintenance time, freeing crews for other duties. They broke down less frequently, meaning more tanks were available for operations at any given moment. Most importantly, they were simply there when needed for combat, rather than sitting disabled awaiting parts that might never arrive. This unglamorous reliability mattered more than any other characteristic in sustained operations. The admission that Wehrmacht crews made, that the Sherman outran every Panzer they had, was not simply about maximum speed specifications. It was about operational mobility, the ability to sustain movement over realistic terrain for extended periods. The M4A3 could maintain higher speeds for longer durations across varied terrain than comparable German tanks. This advantage, seemingly modest in individual engagements, became overwhelming when aggregated across hundreds of tanks operating over weeks of continuous operations. German armor, when it worked, could match or exceed Sherman performance in specific measures. The Panther had better armor penetration. The Tiger had heavier armor protection. The Panzer IV was adequate in most respects. But German tanks broke down constantly, requiring extensive maintenance and frequent repairs that removed them from operations. The Wehrmacht could not sustain the operational tempo that American armor maintained because German equipment simply did not work reliably enough. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.